Hi and welcome to the third class on time and work. I hope you have watched the videos of the first two classes. In case you have not, I'll strongly advise you to go and watch those videos first, solve the question that we did in those, solve some more practice questions, and then come back to this class because the concepts are all interrelated. In the first class, we understood the concept of time and work. We did questions where one person, two people, more people are working together, and we saw that how much time will they take to finish the work. In the second class, we discussed the concept of man days and man hours, and we did questions related to that. In this class, we are going to touch upon the very important concept of efficiency and wages. Wages is what will people be paid when they work together on a project or on completing a piece of work. Okay, so let's dive in straight away. So let's understand efficiency. Okay, now efficiency, like we discussed earlier, work we were not measuring. We were saying 1 unit of work or so many man days of work or so many man hours of work. We were not really measuring work. Similarly, efficiency also cannot be measured. We cannot say that what is his actual efficiency. Then it becomes physics. We are doing math. So what we do is we basically compare efficiencies, and that comparison is good enough for us to decide who is more efficient, who is less efficient, who should get paid what. So efficiency we will only be comparing, first part. Okay. Efficiency also decides the amount of work that will be done by a person, not number of days. Okay, so basis your how efficient you are, you will be doing certain amount of work. It does not matter how many days you work. If you work for 20 days and you're zero efficient, then you'll end up doing 0% work only. Okay, so efficiency tells me how many days I will work, and it also tells me how much I will get paid. Okay, so your total work done basically is number of days into your efficiency. Okay, efficiency is directly proportional to 1 day's work. So if I have to measure the efficiency, let's say A and B. Okay, A finishes a work in 10 days, B finishes the same work in 15 days. Who is more efficient? Is A more efficient or B more efficient? Obviously A, right? Because A finishes the work faster. So efficient means he does more work in the same time. Okay, so how do you compare efficiencies? Someone who does more work in the same time is more efficient. As simple as that. So A does 1/10 of the work in a day. B does 1/15 of the work in a day. So this is the comparison of their efficiencies. 1/10 is to 1/15. Very simple. So efficiency is directly proportional to 1 day's work. This is very important, and in fact this is what we do use in all the questions. Now 1/10 is to 1/15 may not look good because it's a fraction. So let's multiply this by how much? 30. And it's a fraction, it's a ratio, so I can multiply both of them by 30. When you multiply them by 30, you get 3:2. This is the ratio of their efficiency. So the ratio of their efficiency is 3:2. That means A is 50% more efficient than B. Right? That's what I can say. A is 50% more efficient than B. The ratio is 3:2. Okay. So fourth and fifth point is same. Efficiency is inversely proportional to days taken to finish the work. Days taken is 10 and 15. So their efficiency is 1/10 is to 1/15. Okay, so same thing. And wages, very important. Wages are paid for the amount of work done, not for the number of days you worked. Okay, so for the amount of work done. Okay, so just to apply this here, A and B, let's say they work together. So they will 1/10, 1/15. So you get 30, you get 3 plus 2, which is 5/30. That means 1/6. So in 1 day they do 1/6. That means they finish the work in 6 days. Okay. Now, how are you going to divide your money or your payment between A and B? On the basis of the efficiency. So 3:2 is the efficiency. That is what the payment also will be. The payment will be in the ratio of 3:2. That means A will get 3/5 of the payment and B will get 2/5 of the payment. So if you have to pay 1,000 rupees, okay, A will get 3/5 of 1,000. That means 600 rupees. And B will get 2/5 of 1,000. That means 400 rupees. Why? They both have worked for 6 days. Why will you pay different amounts? Because they have not done same amount of work. Payment is always on how much work you have done. And that's very easy to check. A does 1/10 of a work in a day. So in 6 days, A will do 6/10. Okay. And B will do 6 into 1/15. For A also, instead of 6/10, let's say 6 into 1/10. Okay. Because 1/10 is his 1 day's work. He works for 6 days, so he'll do 6 into 1/10, and B will do 6 into 1/15. Now, 6 into 1/10 is 6/10. This is 6/15. So 6/15 is nothing but 4/10. So you can see that A has done 6/10 or 60% of the work, and B has done 4/10 or 40% of the work. So when A has done 60% of the work, A should be paid 60% of the amount and B should be paid 40%. So that is what it boils down to. So how many days you have worked does not matter. Both of them have worked for 6 days. But they have not done same amount of work. Wages are always paid on the amount of work that you have done. And amount of work is directly proportional to your efficiency. This one. When your days are same. So when your days are same, let's say number of days is a constant, then work done is directly proportional to your efficiency. So efficiency is a good enough criteria to decide who should be paid how much. Okay. When efficiency is 3:2, the payment should also be 3:2, provided they have worked for equal number of days. Okay. Otherwise, if days are different, the best method to find out who should be paid how much is you just see who has done how much work. And how much work you have done, that much payment should be done to you. As simple as that. Okay. So let's dig deeper and look at a couple of questions to understand this more. So A can complete a piece of work in 15 days. A in 15 days. B is 50% more efficient than A. B is now 50% more efficient. So that means efficiency of A is 1, efficiency of B is 1.5, or I don't like decimals. So efficiency of A is 2, efficiency of B is 3. That is what it means. Okay. And in the previous one, we saw that efficiency is directly proportional to 1 day's work. Okay. And inversely proportional to days taken to finish the work. So going by this, so their 1 day's work is in the ratio of 2:3. Okay. Or the number of days to finish the work should be reverse of this. Okay. So what do you think? If A can finish the work in 15 days, then B will finish the work in how many days? Less than 15 or more than 15? Definitely less than 15 because he's more efficient. Okay. Will it be 10 days? If it is 10, just for you to understand, then their efficiency will be 1/15 is to 1/10. Okay. Multiplying by 30, you will get 2:3. That's what we wanted. Right. So 2:3 basically means that number of days required will be 15:2. So basically what happens, you can see that 10 into 3 is a constant, 15 into 2 is also constant. So efficiency into number of days to finish the work is a constant. Right. So when you get 2 and you get 15, 2 into 15 is 30. Here you know it is 3, so it has to be 10, right? So that you end up with the same value of 30. right? So that is efficiency into number of days is a constant. So if we do this once again, just to understand this, A and B, A does in 15 days, their efficiency is 1:1.5, which I write as 2:3. So 2 into 15 is 30. 3 into whatever should also be 30. So obviously this should be 10. That's all, as simple as that. Okay, 1/15 plus 1/10, you know, is 5/30, 1/6. Hence, they will finish the work in 6 days. That is the concept. Okay, great. Let's do a few more questions and understand this more. This is the question that we had done in the first class. Okay, now I've just added, we are revisiting this question because now we want to look at this from the wages angle. Okay, so A and B can complete work in 12 days. And let's do this using the LCM method. For those who have forgotten, it will be good revision. B plus C is 15 days and A plus C is 20 days. Okay, 12, 15, 20, LCM is 60. So we say that the work is 60 units. A and B, they do work in 20 days. That means they do 60/12, 5 units per day. They do 4 units per day. They do 3 units per day. So together they do 12 units. But these 12 units are done by 2 times A plus B plus C. Okay, that means A plus B plus C do 6 units in a day. Total work to be done is 60 units. That means they will finish the work in 10 days. So work is done 10 days. Okay, now we have to look at their efficiencies. First, we'll have to find out how much A does, how much B does, how much C does, right? Okay, we don't know how much work they do in a day. Okay, so if I look at this here, A, B, C, and let's continue through the LCM method only. Let me erase this part. Okay, A, B, C, they do 6 units in a day, out of which B and C, they do 4 units. If I subtract this, that means A does 2 units in a day. Okay, total work is 60 units, so A will need 30 days. So A will finish the work in 30 days. Instead of B and C, if I look at A and C, they do 3 units in a day. That means B, subtracting them, will get B will do 3 units in a day. Total work to be done is 60 units. 60 divided by 3 is 20 days. So B will do in 20 days. Okay. And for C, instead of A and C, let's take A and B. A and B, they do 5 units in a day. That means if I subtract this from this, I'm left with C will do 1 unit in a day. To do 60 units, he'll need 60 days. So C is 60 days. Okay, so we have completely solved this through the LCM method. Okay, now their efficiencies. Efficiency of A is to B is to C is 1/30 is to 1/20 is to 1/60, because efficiency is proportional to 1 day's work. So 1/30 is to 1/20 is to 1/60. If I multiply this by 60, I'll get 2 is to 3 is to 1. So their efficiencies are in the ratio of 2 is to 3 is to 1. So the payment should also be in the ratio of 2 is to 3 is to 1. 2, 3, 1 is 6 parts. 6 parts of 1500 is 250 each. So he should get 250, he should get 750, and he should get 500. So 500, 750, 250, answer should be choice 3. Right? That is how you will solve. How did we do the last part? Just to explain again, in case I did it too fast. When you have arrived here, what you basically do is 2, 3, 1 is total of 6. That means A should get 2 by 6, B should get 3 by 6, and C should get 1 by 6 of what? Of 1500. So 1 by 6 of 1500 is 250, 3 by 6 of 1500 is 750, 2 by 6 of 1500 is 500. Okay, this is one method. The second method is what I told you, that we don't bother about efficiency and we just look at the amount of work done. We know that the work has got over in how many days? 10 days, right? So work has got over in 10 days. So now if you look at A, for example, A does how much work in a day? A does 1 by 30 in a day. 1 by 30, and he has worked for 10 days. So he has done 1/3 of the work. He should get 1/3 of the payment. He should get 500 rupees. B does 1/20th of the work in one day. He has worked for 10 days. So he has done half the work. He should get half the payment. Okay. And C does 1/60th of the work. He has worked for 10 days. He should get 1/6 of the payment, which is 250. This approach also is fine. How much work you have done, you get paid in that ratio. And that again is nothing but the ratio of efficiency. So finally you'll end up with the same answer. Okay, so both the approaches are absolutely fine. And that is how you basically decide on the wages between people. Okay, so I hope we are good here. Okay, let's see one more question. A can paint a house in 60 days while B can paint it in 84 days. A started painting and after 10 days B and C join. Together they complete the painting in 14 more days. If they are paid 21,000, then the share of C for the work done is how much? Same thing, you basically have to just find out. So here efficiency would be difficult, but we can find out how much work they have done, because wages will be paid as per how much work you have done, right? Okay, so if you see, A has worked for how many days? A started painting after 10 days, B and C join, and together they complete, B and C have joined together, right? They have joined after 10 days and they complete the painting in 14 more days. And so they work for 10 days and 14 more days. So 24 days. So amount of work done by A, in one day A does 1 by 60 and totally has worked for 24 days. So he will do 24 by 60 or 4 by 10. So he should be paid 4 by 10 of 21,000. So 2100 into 4, he should be paid 8,400. As simple as that. Okay. B has worked for 14 days. B does 1 by 84 in a day. He has worked for 14 days. So 14 is 1 by 6. So he should be paid 1 by 6 of 21,000. Right? 1 by 6 of 21,000, which will be how much? 3,500. So B should be paid 3,500. For C, the problem is I don't know C finishes the work in how many days. So what is his efficiency and all? I have no information. So one method is a longish method where I say, okay, A has worked for first 10 days. So 1 by 60 into 10 plus A does 1 by 60 in a day, B does 1 by 84 in a day, C does 1 by C in a day. Together they work for 14 days to complete the work. So I make this long equation and I find the value of C. Okay, but why do all this? This doesn't help it. I already know that A has got paid 8,400, B has got paid 3,500. Balance should be paid to C because they have finished the work. So the whole payment will be made to them. Total payment was 21,000. So if I see, these two people have got paid 8 plus 3, 11,900. Okay, they have got paid 11,900. Total payment was 21,000. So how much is left? 9,100. So this 9,100 should go to C. That's all. That is my answer. Why bother about what is the efficiency of C, how much work he does in a day and all that? That is all complication which doesn't serve any particular purpose. So I can very easily avoid that. 9,100 becomes my answer, right? In case you want to find out, of course, you can go ahead and do that, but that does not help. In fact, from here, I can actually reverse calculate that A got paid 9,100. Let's do that. C got paid. So C, let's say in one day he does 1 by C and he has worked for 14 days to get paid. So this is the amount of work that he has done, and into 21,000, right, is what he get, and this is equal to 9,100. I can use this actually. Okay, and through this you can find C and all, but that is not required, not asked in the question. I only need his payment, and since C's payment I cannot find out directly because I don't know his efficiency, let me find for A and B, which is very simple, and the balance will go to C. So that is the answer for this question. I hope we are clear here. Okay. Okay, so let's look at this question. This question says, at their usual efficiency level, A and B together finish a task in 12 days. If A worked half as efficiently as she usually does, half as efficiently. Okay, so let's say A and B, normally they finish their work in A days and B finishes in B days. Okay, so in one day, A will be doing 1 by A and B will be doing 1 by B. This is normal, right? And the equation will be 1 by A plus 1 by B is equal to 1 by 12. Now, if A worked half as efficiently as she usually does, now when she works half as efficiently, I'm sure you understand that the time taken will become double. So A will now take 2A days. Okay, because efficiency and time taken are inversely related. You are more efficient, you will take less days. You are less efficient, you will take more days. So if you work at half your efficiency, time taken will double. Okay, and B has worked thrice as efficiently. Thrice as efficiently. So for B, the time taken should become B by 3. Right? So this is the revised data. Okay. In this case, 1 day's work will be 1 by 2A and it will be 3 by B. Okay, so my second equation is 1 by 2A plus 3 by B is equal to 1 by 9. Okay, so then how many days A would take to finish the work? So I need A, so B I should cancel. So let's multiply the first equation by 3. I multiply this by 3. So this becomes, let me erase this line. So this becomes 3 by A plus 3 by B is equal to 3 by 12. Okay, and let me subtract this. So minus 1 by 2A minus 3 by A. Okay, so in fact 3 by B gets cancelled. So I have 1 by 2A minus 3 by A is equal to 1 by 9 minus 3 by 12. Now 3 by 12 is nothing but 1 by 4, right? So this is 1 by 4. 9 and 4, the LCM is 36. Okay, so 1 by 9 minus 1 by 4. You will get a negative value. You will get 4 minus 9. Okay, and here also, if I take 2A as the LCM on the left hand side, 2A, you will get 1 minus 6 is equal to minus 5 by 36. Okay, or this is also minus 5. Minus 5 gets cancelled. 2 and 36 will give me, so A is equal to 18 days. A is equal to 18 days, and this is your answer. So normally, now let's understand this data. What does it mean? Normally A finishes the work in 18 days. Okay, and if I put that data here, you'll get 1 by B is equal to 1 by 12 minus 1 by 18. 12 and 18 will give a LCM of 36. 3 minus 2, 1 by 36. That means B normally does in 36 days. And so 18 days, 36 days, 18, 36. The LCM is 36. So if the work is 36 units, A does 2 units in a day, B does 1 unit in a day. Together they do 3 units in a day. So to do 36 units, they will need 36 by 3, which is 12 days. Okay, this is when they work at normal efficiency. Now when they work at revised efficiency. Now if you say A will now take 2A days. 2A days, that means A will take 36 days. And B will take B by 3. B is normally 36, 36 by 3, that means 12 days. Okay, so now these are the values. So A and B is 36 and 12. LCM of 36 and 12 is 36. So A does 1 unit of work, B does 3 units of work. Together they do 4 units of work. Okay, so together they do 4 units of work. So 36 units of work, if they do 4 units per day, they are going to take 9 days. Okay, that is what is mentioned here. Answer we already found. I'm just trying to explain to you how does this efficiency work. Okay, so always remember that your time taken, okay, and this is what we had discussed in the concept, time taken is inversely proportional to efficiency. You are more efficient, you will take less days. You are less efficient, you will take more days. Okay, so going back once again to the concept here, yes. So if you see, efficiency is inversely proportional to the time taken, days taken to finish the work. 1. Okay, or I can also say efficiency is directly proportional to 1 day's work, which is same, right? So if A and B finish the work in 10 days and 15 days, then their efficiency is 1 by 10 is to 1 by 15. Okay, these are the number of days they take. This is the efficiency. So efficiency is inversely proportional to 1 day's work, or efficiency is inversely proportional to days taken, or efficiency is directly proportional to 1 day's work. Both of them basically mean the same. So their efficiency is 1 by 10 is to 1 by 15. And I told you normally to avoid these fractions, let's multiply this by 10 and 15 LCM, which is 30. If I multiply both of them by 30, you'll get 3:2. That means their efficiency is in the ratio of 3:2. If they have to be paid, A will be paid 3 by 5 and B will be paid 2 by 5. So that is the whole concept around efficiency. Okay, so I hope we are clear with this. And this is the question that we just solved. Fine. So I think this completes our third part, where we discuss the concept of efficiency and wages. Okay, because both are counter related. You pay people based on their efficiency, which decides how much work they will do. You don't pay people on the basis of the amount of work, on the number of days worked, but on the amount of work done by them. Okay, so do go through the concepts that I've discussed, do these questions and solve some more questions from your study material so that you are completely confident on this. I told you in the start that time and work will give you few questions for sure in each and every exam. So you have to be on top of this. Okay, and once you've done all your revision and practice and all, then come to the next class where we are going to discuss pipes and cisterns, which is a very unique case of time and work, where for the first time we will look at the concept of negative work. So far we have only looked at positive work, but in pipes and cisterns we are going to look at and explore the concept of negative work. Very, very interesting. So look forward to you being there in that class. Thank you so much. Take care.